Okay, so far in problem 16 and 10.2, we have what? Taken A, B, and C as 42, 19, and 30. Said we want to find angle A. So we drew a triangle, right? And then we labeled some sides. Specifically what we labeled was that angle A went across from 42. And then we wanted to apply the Pythagorean, or the what to this? Law of cosines, which is almost the Pythagorean theorem, right? So I went and found the law of cosines in my brain. That was this part of the quiz. And then we plugged in all this stuff, so we got to here. Yes? Okay. And then somebody want to give me a little bit of simplification on the stuff here? What's 42 squared?
1,764.
1764? Okay, so I have 1764 equals 900 plus 361 minus 1140 cosine of angle A. You guys with this?
Yeah.
All right, so what am I looking for here?
Cosine A.
Yeah, so right now I'm looking for cosine of A. Ultimately here I'm trying to find A, yeah? You guys see that? Unfortunately in my expression all I have is cosine of A, so I'm going to try to find that. So how do I also isolate that thing here?
Get that, put that on that.
Get it by itself, right? So subtract 900 and 361. So I'm going to subtract 900, subtract 361. What am I going to get? 500 what? 503 is minus 1140 cosine of A, right?
Negative 11.
Cool. So take this business, divide both sides by 1140 minus 1140, and I'll get cosine of A equals what?
Well, approximately. Right, unless you want to just leave
Let's
it
go
over.
like this.
Okay.
Let's say it's 503 divided by negative 1140. Cool. Now what do you want to do to both sides? So now I want to uncosine both sides. You guys see that? I have no idea how to do that because I haven't taught you guys how to uncosine things. Okay, does anyone know how to uncosine things, at least approximately? Guess. How do you uncosine things? Yeah, so there's a button for uncosine things on your calculator. It's a button that looks like cosine raised to the negative 1 power, right? You guys remember inverse functions from algebra 2 or something, maybe?
Yeah.
So all this thing is the unfunction for cosine. So I'm going to uncosine both sides. What I'm going to end up with is A is cosine inverse of 503 over minus 1140. Somebody want to get me an approximation for that out of their calculator?
116.82
What mode are you in?
degrees.
Oops, 0.82 degrees, right?
118.
So adjusting for rounding. This is what they wanted for the problem, right? You guys see that? Okay, we need to have a longer discussion about how to uncosine things because there's some subtlety here. Why is there a subtlety here that I'm not really highlighting right now? Maybe what's the concern? You guys remember what the graph for cosine looks like?
Vertical line test?
Close.
Horizontal?
Yeah, this thing fails a horizontal line test, right? So this thing doesn't have an inverse. So what the hell is this thing? You guys see that? Like, I think it gave me the answer I want, but what the heck is it doing? Let's figure it out later. So for right now, in a triangle, this thing will work just fine. Cosine inverse works exactly the way you think it would in a triangle. Outside of triangles, things are a little wobbly because outside of triangles, there are problems with the horizontal line test. You guys see that? Like in the triangle angles, the only ones I can really think about in a triangle, right? They start at 0 and they go to 180. So in a triangle, I'm good because the blue part's the only one that makes any sense. You guys see that? And it passes the horizontal line test. You guys see that? Okay, so you can use this thing in triangles for now. Later we'll talk. Again, louder.
Why did you switch A equals 42 to C?
Good. So here in the problem, right, I had A was 42, B was 19, and C was 30. So I went and drew some random triangle, and then I labeled the sides in order of length, right? So I took the long side, I called it 42, took the middle side, I called it 30, and I took the short side and called it 19, right? Then, what did I know about 42? Yeah, this is the side A, so it's opposite angle A, right? But what does the law of cosines say about the side opposite the angle you want to know about?
Hypotenuse.
Yeah, that's got to be that C side. See that? So in the problem, right, they presented me with angle A is opposite this 42 side. That meant that in the law of cosines, this angle A was going to have to play the role of the angle theta, right? And this long side C, that was going to, or this long side A was going to have to play the role of C in law of cosines. So the black is the way the problem was presented, and the blue is the way the law of cosines runs. Does that make sense?
Yeah.
Stop, please.
Why not, for the sake of not confusing some people, use different letters for the problem? Different letters
That would be an extremely good idea.
but nobody does it.
And no one does it that way. Basically, they screw with you. Sorry. Yeah, this is a really common thing. I wish I could give you law of cosines with different symbols so that this wasn't the case. But yeah, we always give you triangles with A, B's, and C's. And then we also give you law of cosines in terms of triangles. But they're not necessarily the same triangle arrangement. So, sorry. Cool? You guys okay with that? Just be a little wary of like the A, B's, and C's and the stuff you put in here. Not necessarily the same. Cool?